Welcome to Unit 4, Part 3, some more CPU scheduling practice. We will be doing 3 algorithms in this CPU scheduling practice. We'll do priority, preemptive priority, and round robin. So just to remind you about the calculations, we will be calculating turnaround time, wait time, and response time per process, and then averages. So first we will start with a non-preemptive example called priority. In this case, we have all processes have arrived. They've arrived at time 0 at the same time, but we're going to queue them up and use the algorithm where priority 1 is the highest. So you can see the priority column. And so let's get started. We start at time 0, and we're going to pick the one that has the highest priority, which is P2. It will go for 1 time unit. And this is a non-preemptive version, so it'll finish its CPU burst and it will be done. Now the current time is 1. We will pick the one that has the next highest priority, which is P5. It will go until time 6, and it will complete its CPU burst, and it will be done at time 6. Now the current time is 6, so if we take a look, the next one to go will be P1 until time 16. And now the current time is 16. We will run the next priority, which is P3, until time 18, followed by P4 until time 19. Now, since we have 100% CPU utilization, if you add up all of the burst, it should equal 19. And since we don't have any preemption or any extra waiting time, the wait time and the response time will be the same because all of the processes only waited 1 time. And the assumption was that they all arrived at time 0. So we will take a look now that P1 arrived at time 0 and first got the CPU at time 6. So P1's wait time is 6. P2 arrived at time 0, first got the CPU at time 0. So P2's wait time response time is 0. P3's wait response time is 16. P4's is 18, and P5 waited 1 time unit before getting the CPU. And then to calculate the turnaround time, you take the last time when it terminated and subtract the arrival time. P1 finished at time 16, P2 at time 1, P3 at time 18, P4 time 19, and P5 time 6. So with that, you could add them all up and divide by 5, and you would get the average wait time and the average turnaround time. Moving on, this time we're going to do preemptive example. In this case, we have them arriving at staggered times, so we need to take that into consideration, but we still have priority 1 the highest. So let's get started. At time 0, we have P1, but because P1 is a priority 3, if a priority 2 or a priority 1 arrive, P1 will be preempted. So you can notice that at time 3, we will have the arrival of P5, which is a priority 2, which is a higher priority than P1. So P1 will be preempted and will have a 7 time units of CPU burst left and a new arrival time at time 3. Now P5 will go. Since P5 has a priority 2, it may be preempted by a priority 1, which this is the case that P2 is going to arrive at time 4, and P5 will now be preempted and we'll have 4 units of CPU burst left, and we'll have a new arrival time of time 4, and now P2 will go. Now it doesn't matter how long P2's CPU burst is because P2 is the highest priority, so it will get to stay on there and nothing will preempt P2, and P2 will finish at time 5. Now the current time is 5, and in our ready queue we have P3, P1, and P5. So we're going to pick the one that has the lowest priority, which is P5, and P5 will finish at time 9. And now the current time is 9, and all of them are in the ready queue, and now it's just a matter of doing priority-based scheduling. So the next one to go would be P1, finish at time 16, and P3 finishing at time 18, and P4 finishing at time 19. So it's very important that you get the Gantt chart right, and once you get the Gantt chart right, you can make your calculations. So to make your calculations for the response time, you take the first time that it gets on the CPU and you subtract the arrival time. So P1 first got on the CPU at time 0 and arrived at time 0, so P1 didn't wait at all. P2 first got on the CPU at time 4 and arrived at time 4, so P2 didn't wait at all. P3 had to wait 14 time units before its first CPU burst. P4 had to wait 12 time units before its first CPU burst, and P5 had to wait 0 time units. It arrived at time 3 and got on the CPU right away. Then to calculate the turnaround time, you take the last entry in your Gantt chart and subtract the arrival time. So P1 finished at time 16, arrived at time 0, so P1's turnaround time is 16. P2's turnaround time is 1. P3's turnaround time, P3 finished at 18, arrived at 2, so P3's turnaround time is 16. P4's turnaround time is 13, and P5's turnaround time is 6. And now to get the wait time, you just take the turnaround time and subtract the burst time. And that will give, because the process can only either be waiting for the CPU or on the CPU, so that will give you the total time. You could also take the time from when it got into the ready queue and sat and waited. So P1 waited 0 and then waited 6. Or you could take 16 and subtract the burst, which would be 10. And so P1's wait time is 6, P2's wait time is 0, P3 waited 14 time units, P4 12, and P5 1 time unit. And then you take these results and divide them by 5, and you would get the. In round robin is like first come first serve, only it is preemptive. Each process will get a certain amount of time on the CPU. So in this case, all of the processes arrive at time 0, and each process will get 4 time units on the CPU. So we just go through them and let them all have 4 time units, and let's do the exercise. So at time 0, we are assuming they arrived in this order, P1, P2, P3. So P1 will go for 4 time units, and then it will have 20 time units left. P2 will go for 4 time units, and it will have 5 time units left. P3 will go for 4 units, and it will have 13 time units of CPU burst left. Then we just run through them again. P1, P2, P3. So now the current time is 24, and we have run through each of our processes 2 times. And now P1 will go again for 4 time units. Then P2 will go, and now P2 is completed. Then we do P3, P1. Now we just go through P1, P3, P1, P3, P1, P3, until at last P1 finishes, and the current time that they all finished was time 50. So in order to calculate the response time, you take from the arrival time, which is 0, until the first time. So P1's response time is 0, P2's is 4, and P3's is 8. To get the turnaround time, you take the last entry in your Gantt chart and subtract the arrival time. P1 is 50, P2 is 29, and P3 is 46. And then to get the wait time, you take the turnaround time and you subtract the burst time. So P1 is 26, P2 is 20, P3 is 29, and you can take these amounts and add them up and divide by 3, so you could get the averages. But you could also add up to get the wait time. P1 waited 0 time units, then 8 time units, then 8 time units, then 5 time units, then 4 time units, then 1 time unit, and that equals the same. But the easier way to do it is to take the total time and subtract the burst time, because in this case, P1 is only going to be either waiting for the CPU or on the CPU. So that concludes our priority, preemptive priority, and round robin practice. And thank you very much.